Alright, so in this Algebra 1 video, Chapter 3, Lesson 1, we're going to talk about graphing linear equations. We're going to use some skills we've talked about in the past. Those of you who remember graphing in Chapter 5 of 7th grade last year, that's a bit of what we're going to be doing here. So graphing linear equations. Our objective is, as the student, I can identify linear equations, intercepts, and zeros, and I can graph linear equations. We're going to do all this because we're going to apply what we know about constant rates of change and our coordinate plane graphing skills. Alright, so let's start off with some vocabulary. First things first, let's make sure we're clear what a linear equation is. A linear equation is an equation that forms a straight line when you graph it. Meaning, remember, a linear equation, it's like a function. It's inputs and outputs. When you put in inputs, you get different outputs. So you get a bunch of ordered pairs, a bunch of x's and y's that go together. So when you have all your ordered pairs, you're going to graph them, and they will go in a straight line if it's a linear equation. So in other words, when you graph it, it'll be a straight line like this example at the bottom. So when you have linear equations, they have things called intercepts. And you have an x-intercept and you have a y-intercept. So in this example, take a moment to sketch this example. It doesn't take very long, and you don't even technically need graph paper to do it. Just if you don't have graph paper, make sure you include some evenly spaced tick marks like this so you can see what these values are on the graph. So it's a way to keep track. But if you have graph paper, that makes it a little bit more neat. All right, anyways, so in this example, our x-intercept is right here. So our x-intercept has a value of, that's 3. So our x-intercept is 3, and the ordered pair of that x-intercept is 3, 0. The x value is 3, the y value is 0. It did not go anywhere up or down. Now our y-intercept for this example is right here. So our y-intercept is 2, and the ordered pair of the y-intercept is 0, 2. So, because you went nowhere left and right, but you went up to where it crosses. So this is where our line crosses our axes. Now, notice this. At the x-intercept, y equals 0. And at the y-intercept, x equals 0. That's always going to be the case. When you find one of their intercepts, it's because the other letter, the other variable, was 0. That's that, and we're going to use that in a minute to actually find them on purpose if we don't have the equation, or excuse me, if we don't have the graph to look at. Okay, so that's intercepts and linear equations. Okay, so on this page of vocabulary, I want to emphasize, we're only going to talk about the first one, the standard form that I gave you all that space for, but this page is extremely important. This page includes a lot of lifeguard perspective about all the main ideas of how to manipulate linear equations, the different formats. So there are 3 main formats for linear equations. The one that we're going to focus on today is standard form, but I want you to at least write the other formats, and I want you to at least write down the other formats and the template of what they look like, because you'll notice for y equals mx plus b, y is all by itself. I want you to recognize that when y is all by itself, it's in slope-intercept form. And for point-slope form, we'll get to that later, but point-slope form is going to be your best friend when it comes time for us to write linear equations given really little information about a situation. So I at least want you to have all these written down, but the one we're going to focus on is standard form. Now, here's how you know when things are in standard form. You know things are in standard form when your variable terms, meaning your x and your y, are on the left side. But let me be more specific, just so we're clear. The things underlined in blue, so you can just underline them if you want, these items will be numbers. Those will be numbers. So an example of what I'm talking about. So an example would be, we could say 2x plus 4y equals 7. That would be an example of an equation being in standard form. So you know an equation it's in standard form when the variables x and y are on the left, and the only thing on the right is your constant term, meaning your whole number. I mean, well, it doesn't have to be a whole number. It'll just be a number without a variable. So C stands for your constant number, meaning it's not a variable because it doesn't have letters that change. It is just one number. In this case, it's always 7. It doesn't change, so it doesn't have variety, so it's not a variable. So your variables will be on the left and your regular old number will be on the right. That's how you know it's in standard form. And that's the form we're going to talk about. That's what we're going to manipulate and work with in this section. But I at least want you to be able to keep track of the main differences of these forms. It is going to become almost like a vocabulary type deal where I would like for you to memorize what they look like so you can automatically recall them. And again, I promise you we'll give more details on these other formats down here in the future, but for now I just want you to recognize them. That's our goal. One more thing I'm going to point out about standard form. Standard form tends to be the format of equations that usually are easier to interpret verbally when you're reading a word problem. Quite often, sometimes we interpret them into the format of standard form, sometimes for certain questions. But many times, we interpret things into slope-intercept form without realizing it's slope-intercept form. We put them in that format. So to make sure we're covering our objectives, our first part of our objective is I want to be able to identify linear equations, meaning knowing when it's going to be a linear situation. You know it's a linear situation when it has a constant rate of change, meaning when there is just multiplying or dividing going on in your question, or fractions, but there are no exponents, there are no divided by variables. It's simply just going to be primarily multiplying, adding, and subtracting, no exponents. That's how you know you're generally going to have constant rates of change, meaning your line's going to go at a steady rate. Your line's not going to curve, your line's not going to go do zigzags. It's going to be a smooth straight line going up, going down, things like that. That's what we're talking about. Now, we also said we're going to be able to identify intercepts. So if you're given the graph of a line, you're told find the intercepts, I literally just want you to look at the graph and look at the values where it crosses. That's the x-intercept, and this is the y-intercept. I do want to point out, I should have said this back here, another word for the x-intercept, meaning the one where it crosses the x-axis. Notice, y is 0 at the x-axis. So that's actually a vocabulary word, the word 0. When we say find the zeros or find the 0, lines will only have one x-intercept, so the 0 is the x-intercept. So the 0 is the x-intercept. So I just want you to know it's another phrase for it. It's another name for it. So if it says find the 0, they're asking find the value, find the location where y equals 0. And that's what we're going to find algebraically. And visually, we're going to find just by looking at the graph, looking at that location. All right, we also want to find, and so that was the zeros we talked about. Now we're going to focus on I can graph linear equations, and we're going to find some intercepts visually, or primarily algebraically, but we'll do it visually as well. To make sure we're clear, though, let's make sure we understand, is it a linear equation? And the way to think of that is, can it be rephrased in a standard form? Now remember, I reminded you, standard form is not the only form, but in standard form, each of those items I underline in blue, those items can be negative numbers, they can be fractions, they can be decimals, they can be any of them, but they will be numbers. So if you can rephrase it into standard form, meaning get all of your variables to the left and then the constant number to the right, if it's in the format of something times x plus something times y equals c, or minus in here, it doesn't have to be plus, then it's in standard form. So if it can be rephrased in that way, then yes. I also pointed out to you, I gave away that if it has no exponents, if it's got no divided by variables, that's usually a good indicator as well. So let's see if we can get all of our variables to the left side. And I notice we have a 3x on the right side. So what I'm going to do is I'm going to move 3x to the left side and see if that'll get all of our variables to the left. So minus 3x from both sides, using the skills we normally use. So to do that, after that we have 2x plus 6y equals 2. Now let's see. Standard form is the format of ax plus by equals c. We literally have 2x plus 6y equals 2. So imagine ax plus by equals c. Yes, this is standard form. So yes, this is a linear equation. So question number 1, that is a linear equation. Now if you had x times y equals 6, we could try to put this in a standard form, but the truth is, standard form, you'll notice x and y are separated by addition or subtraction. Right now, they're stuck together by multiplication. So even if we divide them away from each other, like let's say we divided both sides by x just for funsies, you don't necessarily need to write this, but if we did that, we'd end up with y equals 6 divided by x. So no matter what we do, we'll never be able to get x and y separated from each other with addition or subtraction. So, and I also mentioned before, you can't have divided by a variable if it's going to be a straight line. So in this question, this cannot be written in standard form. Therefore, this is not a linear equation. Number 2, if you were to graph it, it would not be a linear equation. It would end up being a curve of some kind. Alright, so let's do some graphing. In general, for our purposes, because right now we're learning the basics, there are 2 ways that we're going to talk about how to graph. There you have your table of values method, which is your input-output method. We did a lot of that last year, so that should sound very familiar, where you choose values for x, you plug them in, you see what you get for y, and then you have an x comma y, you have an ordered pair, you graph those ordered pairs, you draw a line through them. That's going to be graphing in the input-output table. We're not going to spend a lot of time on that one, because that's one that we were all very good at, and it's one we were also good at the beginning of this year when we were reviewing. We're mostly going to, the new thing to do though is be graphing by intercepts. So that's one we're going to spend a little bit more time on. So that's what we're gonna do some examples of graphing by finding the intercepts. It also happens to be a bit faster than doing the table of value method. So if you're instructed to graph this equation, x plus 2y equals 4, and you're instructed to graph it by using the x and y intercepts, that's one of the fastest ways that we're going to know for now on how to graph these. So what I want you to do is I want you to find the x and y intercepts. Now, before we do that, I want to remind you what that means. Remember what we said before, at the y-intercept, x will always equal 0 because at the y-intercept, it's not somewhere on the y-axis, but to be on the y-axis, you do not go anywhere left and right. You only go up and down. So x will always be 0 at the y-intercept. Same thing goes for the x-intercept. The x-intercept, y will always be 0. So that's what we're literally going to do to find them. So if we wanted to find the x-intercept is where y is 0. So in order to find the x-intercept, you literally make y 0 and solve for x. That's what we're going to do. So x plus 2, we're going to make y into 0, and it's still going to be equal to 4. So I'm going to literally make y 0. So I'm going to plug in a 0 into y spot. Those are supposed to be parentheses. So now solve for x. That's what you're going to do. Well, 2 times 0 is 0, so it cancels out. So you're left with, in this case, x equals 4. Well, hey, you just found your x-intercept. Your x-intercept is x equals 4. So if you have your, you can do a quick sketch of your coordinate plane. I'm going to do that real fast. So just draw 2 quick lines. It doesn't really matter if they're perfectly straight, but make them close. Ideally, you're using graph paper right now, but you could technically sketch this on regular paper. Okay, so at x equals 4, that's our x-intercept. So 1, 2, 3, so x equals 4 is right here. So that's your x-intercept. Because what we need to do is we need to find 2 points. Because look, if we just have 1 point is not enough information to graph a line. That line could be doing this, that line could be doing that, the line could be doing that, the line could be doing that. So 1 point isn't enough. We need to find a second point wherever it is, because if you have 2 points, there's only 1 line that goes through them. So we need to find a second point. So what we're going to do is we're going to find the y-intercept is what we're going to do next. We're going to find the y-intercept. And to find the y-intercept is where x equals 0. Because if you look at the y-intercept here, x was 0 there at the y-intercept. So make the x 0 and then solve for y. That's what you're going to do. So make the x 0. So I'm going to start by x comes first. So it's going to be 0 instead of x plus 2y equals 4. So for now, solve for y. So if we do that, we'll have 2y equals 4 because the x is gone. Now we'll divide both sides by 2. And we find out that we have y equals 2. So we're left with y equals 2. So that tells us the y-intercept is 2. So go up 2. So there's our y-intercept right there. That's our y-intercept. Well, hey, look, we now have 2 points, so we are ready to graph our line that goes through these points. We're ready to graph our linear equation of this equation because all we needed was a minimum of 2 points. So draw a line that goes through those 2 points, ideally with a ruler. Alright, so draw your line that goes through those, and then just add some arrows on the end of your line. Sorry, it's in a different color. So you have now graphed this equation by locating the x and y intercepts. Alright, so you try this example. I want you to graph this equation by first finding the x and y intercepts. And notice, I don't even have, I turned off the graph paper for this one because I want to show you technically could sketch these and understand what you're doing even if you don't have graph paper. So take a moment, find the x and y intercepts by doing what we did here, making the other one 0 and solving for it. Hit pause. Alright, so let's start by finding the x-intercept. So to find the x-intercept, you got to make y into 0 and then solve for x. So 2x plus, instead of y, I'm going to leave it blank for now because I'm going to write it in a different color, equals negative 2. So y becomes 0. So now if we solve for x, we'll be left with 2x equals negative 2. So 2x equals negative 2, and then divide both sides by 2. And now you have x equals negative 1, because negative 2 divided by positive 2 is negative 1. So x equals negative 1. So our x-intercept is negative 1, meaning we'll have an ordered pair at negative 1 comma 0. That's what that means. Okay, so I'm going to go ahead and just find the y-intercept now before I go ahead and worry about graphing anything. So then let's find the y-intercept. So to find the y-intercept, we're going to make x 0. So x becomes 0. So instead of 2 times x, we're going to have 2 times 0 in its place. So now you're going to solve for y. So 2 times 0 equals, forgot the y. 2 times 0 plus y equals negative 2. Okay, so now solve this for y, and you'll be done. So 2 times 0 cancels out, so you're left with just y equals negative 2. Oh, look, you found your y-intercept. Your y-intercept is y equals negative 2, meaning you have an ordered pair at 0, negative 2. So you've now found both of your intercepts. You're ready to graph this equation. So like I said, technically you could get away with doing these without a ruler as long as you're relatively neat. So draw your two axes. So okay, draw arrows on them. Okay, your x and y axis. Now we know we have an x-intercept at negative 1. That means go left 1. So we know we're going to have an x-intercept right there. Clearly indicate with a tick mark where it's at. You know you're going to have a y-intercept at negative 2, so that means go down 1. Make these about the same distance apart that they were for your x-axis. Make it consistent. So look, you have two dots. You now have enough information to graph your line that goes through those two dots. Either use a ruler, use the edge of your calculator, use a pencil, the edge of a paper, whatever, and just draw a straight line that goes through those two dots. So look, you've now, this is considered a sketch because I didn't do it perfectly on graph paper like I did in the last example, but basically you still graph this equation by locating the intercepts. Now, for those of you that maybe need a refresher on how to graph by a table of values, like an input-output table, I'm going to include an example of that. And so if you think you need help with that, write that down. If you don't, you do not have to write it. It's one of those things I know we did a lot of last year. But before I do that, I want to give you an overall recap real fast. We talked about some vocabulary. Okay, we discussed linear equations, the intercepts. Another word for the x-intercept is a 0. We talked about the different formats of linear equations. This is a very important slide. This is lifeguard perspective. Being able to tell the difference between each of these formats is really important. So we're focusing on standard form for now, but I promise you, slope and intercept form is going to become your best friend. And your grandfather, your best friend that you're going to use to help you do everything, is going to be point slope form. We'll get to those in the future, but lifeguard perspective, I want you to recognize these. We talked about, is it a linear equation, yes or no? We did some examples by finding our intercepts, because that was a new skill for us that was a little out of the ordinary, and I want to make sure we're focusing on it. So now I'm going to do an example on finding graphing an equation based on a table of values. So if you don't need it, you don't need to watch it. But if you have any doubt, at least skim through it. Make sure you understand the gist of it, but you don't have to write it down. Okay, so I'm going to give you a refresher on how to graph the table of values. So let's say we had this equation. We're going to graph it with the table of values. What that means is we're going to generate inputs, and we make up the inputs. Remember, your independent variable is your x. It's the one you get to choose. We recited those last year. X is your input. X is your independent variable. X is your domain. Y is your output. Y is your dependent variable. Y is your range. Remember, we recited those last year to make sure you knew that those words meant the same thing. So before you do a table of values, it makes your life easier if you get y by itself to begin with. So what we're going to do is we're going to move this minus 2x to the other side using the skills we've been learning. So to move negative 2x, we're going to add 2x to both sides. And once you do this, you're going to have y by itself. So you're going to have positive 2x minus 2, or you can say negative 2 plus 2x. But I'm putting it in purposely in a format where it resembles slope-intercept form, because get in the habit of already putting it in that format, so when it is time for us to use that format for real, we won't hesitate. We'll be good to go. Alright, so anyways, now you have y by itself. Make a table of values. You're going to pick x values, and then you're going to plug them in. But you're going to plug them into that equation, 2x minus 2. And then we're going to get an output for y. And then we're going to have, technically, one more column for our ordered pairs where we're going to put those together. Alright, so let's pick some values for x. I suggest you pick easy numbers. I suggest you pick smaller numbers. So I'm going to pick numbers like negative 1, 0, 1. I'm going to pick numbers that are near the origin. So I'm going to pick negative 1, 0, 1. We choose these, but again, I suggest you choose easy numbers that are near the origin, near 0, because remember, the origin is where the axes cross, so the origin is right there. So pick values kind of around 0 so that you have an idea of what it's doing on both sides. Anyways, you're going to plug each of these in. But before you plug them in, they're all going to set up the same way. They're all going to start off as 2 times something minus 2. We're just going to fill in for that parentheses, essentially what we're going to do for every single question. So negative 1, 0, 1. So now evaluate each of these, and that's going to give you your y value. 2 times negative 1 is negative 2. Negative 2 minus 2 is negative 4. So our output is negative 4. Now for the next one, 2 times 0 is 0. 0 minus 2 is negative 2. For the next one, 2 times 1 is 2. 2 minus 2 is 0. So we now have found a table of values for each of these to where now we're ready to graph this equation. But before we do, I'm going to go ahead and fill in those ordered pairs. So fill in your ordered pairs, and now you're ready to graph away. Alright, so sketch your x and y axis, and now we're going to graph these points on this graph. Now, if you're using graph paper, that would be ideal, you'd be more precise, but for the purposes of just teaching the concept, we can do it with a hand-drawn graph just like this. Alright, so we have a point at -1, -4. So -1 means go left 1, -4 means go down 4. 1, 2, 3, 4. Remember to make an effort to make these evenly spaced. So that one's going to be right about there. Next one's at 0, 2. So that means go nowhere but go down 2. So that one's right there. Next one is at 1, 0, meaning go right 1 and go nowhere up and down. So right there. Now, if you did this correctly, those 3 dots should be an exact perfect straight line. Obviously, if you sketched your graph and it was a little crooked, that might not be in a perfect straight line. But assuming you did what you needed to, or if you're using graph paper and a ruler, they will be an exact straight line. If one of them is not in a straight line, you either plugged it in wrong or you graphed it wrong. Alright, so make an effort to draw a straight line that goes through those. Not too bad, if I do say so myself. I missed a little bit right there in the middle, but it's essentially you get the point. So draw a straight line that goes through them, and you're done. You now graph this equation using a table of values, an input-output table. But I think you'll agree that doing it with the intercepts requires less steps. It tends to be a lot faster. The only difference is sometimes your intercept will be a decimal or a fraction, and so it'll be hard to do that method accurately if you're not exactly sure where it is on the graph. Like let's say the x-intercept was -1.5. Well, -1.5 is going to be somewhere in between -1 and -2. So it might not be as easy to graph it accurately. So for that reason, you want to be able to use a table of values. So different situations sometimes calls for different methods. Alright guys, take care and make sure your notes are complete. We're ready to take this to the next level.